Now that we've had some practice at working with arrays, let's have a look at the linked list data structure. If you've been finding it difficult understanding how to reference different objects, hopefully this practice will start to clear things up for you. This is a model of a singly linked list, which we will be creating today. We are going to make two object classes. One we will call node, and the other we will call linked list. The node is going to take in a variable called data and then store it. It is also going to have a variable called next, and this will hold a reference to an other instance of a node. The linked list is going to have three main functions. The append and the prepend functions are how we will create a new node and decide how to attach it into our list. And we are also going to have a way to delete a node. The head variable is going to hold the reference to the first node in our list. Notice how the arrows are only pointing to the next node, and as we get to the end of the list, the next node is not valid. In a doubly linked list, the node object will also have a variable that will hold a reference to a previous instance of the node. This way, we can go from node A to B and back to node A. Notice that in node A, it does not point back to anything. In this example, C is pointing back to node A, which makes the list cyclic. And in the model for a circular doubly linked list, node A can point back to node C, and C can point forward to node A. The way that we delete a node in a linked list is by setting a node's next variable to its next. This way, there are no more references to the node that we want to delete, and it will eventually be handled by the garbage collector, which Unreal Engine manages for us. Starting off in the content folder, let's go ahead and rename our algorithms folder to algorithms and data structures. Open it up and make a folder for linked list. Open it up. And as usual, let's go ahead and make a widget class so that we can interact with our linked list at runtime. We also need to go back to the game mode and make sure that we are using this widget. Let's create an object class, and let's name it node. Let's make another object and call it linked list. Let's start off in the node. First thing, let's create a variable, call it data, and let's work with a string. Make another variable, call it next. Go ahead and select the variables drop-down. Instead of choosing any of these, we are going to search for the node type, the type that we are currently in. And so we're going to use an object reference for the node that we just created. This is the part that is going to be referencing the next instance of a node. Add a function, call it node, get the data, set it, and let's set it to the input node and give it a return. I actually want to return something out of this node. Let's add an output and let's just call it ref. Select the variable type and let's search node. Right click, search self, and get a reference to self and hook it up. And that is it for the node class. Let's open up our linked list. Add a variable, name it head, go to the variable types, and search node. Let's go ahead and add all the functions that we will be using. Append, prepend, delete, and let's add one so that we can print the list to the screen. We have our functions created, and you can see that we have tabs for each of these functions. Let's go ahead and start with the append function. So append means that we are going to add a node at the tail of the list. We are going to start off by taking in some data. Let's give it an input, call it data, make it a string, and let's save it as a local variable. And when you save it as a local variable, you have to give it some type of an off spelling. The entry point that we have to the list is starting with the head. But if the head is null, and if it is not set to anything yet, then the first node needs to be set to head. Let's first check to see if it is valid. Search is valid. We have two options. Let's take a look at both of them. Is valid is very useful for checking if a reference exists. It's good to start off your functions with checking the conditions if something even exists to be able to do something with it. This node is essentially the same thing as our branch node because it's asking the question if. This is an if statement. This setup and this setup are the same. But because checking if something is valid is so common, it has its own node. The first time this runs through, it's going to run false. So we need to create a node. So let's search construct object from class. Set the class to node. Let's drag out and let's search for that node function that we created back in the node class. Let's set our data into the node. And since we have a reference to our node coming out of this function, let's go ahead and set the head of our linked list to this node and then return to exit the function. If the head node is valid, then we need to have a way to walk all the way down to the tail of the list and add our new node at the tail. Add a new local variable. Let's call it current and make sure that it is the node type. Let's set it, and we are going to give it the same reference as the head node. Drag out and let's give it a while loop. Let's get the current node, drag off, search next, and notice that this is the next variable that we have in our node class. The condition is that while current's next is valid. So while current's next is valid, we are going to set current equal to current's next. Go ahead and pause right now and make sure that you understand what's happening here. Understand that if we have a list of nodes and we are trying to get down to the tail of it, we have to have a way to walk step by step all the way down to the end. We started at the head node, we put it into a different variable that points at the same node, and that variable is called current. And then we are checking if the variable next inside of that node, if it is valid. If it is, then we are going to continue walking down and setting the current node equal to current's next. It will continue to walk down until this condition is no longer true. When this condition is no longer true, meaning that the current node's next is not valid, that means that we are now at the end of the list. Now that we are at the end of the list, the completed pin executes and we can add a new node. Construct object of class, node, call the node function, set the data, and this next part is how it gets attached. We get the current node, which is the tail that we are on, search set next. And now this node that we just created becomes our current position's next node. And this becomes the tail of the linked list. And give it a return node. Let's tab over to prepend. So prepend is similar. Now instead of adding to the tail, you are adding a new node to the head. Just like on append, prepend is going to be receiving data. So let's add an input, call it data, and keep it a string. Let's promote it to a local variable, give it some off spelling. Like before, we need to check to see if the head node exists. So let's get it and let's see if it is valid. If it's the first one, then it's going to be invalid. So if it is not valid, let's construct object of class, node. Let's call the node function, set the data, and then set it as the head. And give it a return node. If the head node does exist, then we are going to create a node and add it as the new head of the list. Let's copy all of this, Control D duplicate. Let's promote it to a local variable, current. Let's set next equal to the current head, and then let's set the head to the current node and give it a return node. And right here is where this new node becomes the head. And that is prepend. Let's move on to the delete function. I'm actually going to rename mine to delete with value. This is to imply that we are looking for a node that contains the data that we are given, and then delete that node. And so as usual, since we are given some data, we need to receive it through the input and store it as a local variable. Like the last two functions, we need to first check to see if the head node even exists. If the head node does not exist, then there's nothing to delete, and we can go ahead and return. If the head node is valid, then since this is the one that we are at, let's first check it to see if its data is equal to the data that we are given. If head's data is equal to our given data. If the head node's data is equal to the data, then we need to delete the head node. But we don't want to delete the rest of the list if there is a list. So the next thing we have to ask is if the head has a next node that it is pointing to. If head's next is valid. If head does not have a next, then we can simply set head equal to null. We just use a setter and we don't plug anything in. And then we return. If head's next is valid, then we are going to set head equal to head's next, and then return. This way we cut off the head and the next one becomes the new head of the list. If head's data does not equal the incoming data, then we need to walk through the list until we find a node where its data does equal our incoming data. Create a local variable, current, set it equal to head. Add a while loop, and now we set up the condition that we continue to loop through if current's next is valid. If current's next is valid, then we are going to continue to walk down the list. But as we walk, we have to ask each node about its data. We are going to ask if current's next data is equal to the incoming data. If current next data is not equal to the incoming data, then we will continue to walk. Set current equal to current next. You want to make sure that you do not give it a return node, because this is where it's going to go back to the while loop to check the condition again. But if this condition is true, if we find out that its neighbor is holding the data that we are looking for, then we need to get rid of it. We then need to ask the question, is current next valid? Is current next? The question is if current next is valid. If it's false, then we can go ahead and get rid of this guy. And we do that by getting current, and we are going to set its next equal to null and give it a return node. If we come down this direction, then what this means is that the current next was going to be the tail end of the list. Otherwise, if the guy that we're getting rid of is somewhere in the middle of the list, then we need to walk around him. To do this, we're going to set current next equal to current next. And then we give it a return node. And that is the delete function. Now all that we have left is the print list function. As usual, we first need to check if the head is valid. If it's not valid, we return. If it is valid, we need to walk down the list and get the data from each node and print it out. Add a local variable, set it equal to head, get a while loop, and the condition is while current is valid. If current is valid, then let's print the string, and we will be printing the current data. Then we set current equal to current next. Once it is complete, we return. Hopefully by now, setting up a widget class is becoming routine. Go ahead and set up your widget so that it implements these 4 functions that we created. Okay, let's run this thing.